Hello everyone. In this video, we're going to have a look at the equation of a plane. Okay, so a plane is a two-dimensional shape, like a piece of paper, and it's sitting there in the air, and it's defined just in those two dimensions. Well, it's a three-dimensional shape because it moves in all three dimensions, but the shape itself is two-dimensional. So you can think of it, yeah, like a flat piece of paper sitting in the air. And the way it's defined, and there's much better videos to watch than mine for these that can show it graphically, but the way that it's defined is by this normal that sticks out from it. So remember, a normal is a vector that sticks out from something that's perpendicular to everything. So that normal is perpendicular to every point that's in that plane. And that's actually how the plane is defined. And so if we've got a normal there, and if we've got some point on the plane, and it could be any point P naught, like we sort of talked about before, if we've got any point P naught, and let's say that P naught is x0, y0, z0, so I've got some sort of initial point there. Then what we can do, and sort of forgive me for this, but if you've got another point which is your general point pxy, xyz, okay. And so if you think about it, that normal vector there will be perpendicular to the line between P and P naught. And so what we know from this straight away is that the normal dot the line from P naught to P, so that vector there will be equal to 0. Okay, and that'll be true for every point on the over every point pxy. So it doesn't matter if you move pxy somewhere else. The line between P and P naught will always be perpendicular to the normal, and that's why we arrive at that. And this here is actually the vector equation of a line. Okay, so that vector equation of the plane. And that's how it's sort of defined. Now, we're going to do an example in a second. I'm going to show you that people rarely use this form of the equation because there's a much quicker way to quickly get to the Cartesian equation. And I might write that down. No, I think I'll show it to you. I'll show you an example. I'll do it sort of back to front. Okay, so let's just, I'm just going to scoot straight down to this example just to show you a couple of things. So find the equation of the plane that passes through a point. So that's my P naught, right? So that's my some point on the plane. That gives me a point to start with, and it's perpendicular. The plane is perpendicular to this, and so that's my normal point there, okay? And so let's say we have, let's point the P being XYZ. So let's say we have this point which is XYZ, which is somewhere on the line. And so then what do we get? Let's have a look at this. And so we're going to have N dot P naught P is equal to 0. So let's have a look at what P naught P is, okay? So just do some aside stuff up here. So our P naught is equal to 3i plus 2j minus k. And my point P, OP naught, and my OP vector is equal to xi plus yj plus zk, okay? Because that's my OP, my position vector of that. So what is P naught P? So that's P naught P is equal to, remember, that'll be P take away P naught. So it's going to be x minus 3i plus y minus 2j plus z plus 1k. Pen's not working so well. So that's my P naught P. If we now put this into the dot product formula that we had before from up here in blue, then we get, let's say, so we're going to have the dot product of this against this, okay, dot product of that and that. So it's going to be negative 3x minus 3 plus 1 y minus 2 minus 2 z plus 1, all of that is going to be equal to 0. Let's expand that, and I just want to show you sort of what happens here. Okay, so that's going to be negative 3x. I'm just going to put all the x's and y's and that sort of thing together, plus y minus 2z. So I've got that, and I'm just going to put everything else on the other side here, okay? So what's going to come onto the other side? So we're going to have -3 times -3, so that would be +9. If I move it to this side, it's going to be -9 over here. And so then, in fact, sorry, I'm just going to do something else. I'm just going to say that's going to be -3 times by, okay, sorry, I'm just trying to make something work to sort of prove why this works. Okay, so yeah, that'll be 9 coming outside, which is 3 times 3. I'm sort of expanding it out a little bit. My apologies, I just want to show you where this is coming from. And then the second thing, -2, so 2 will come over to here, so it's going to be sort of like 2 times 1 over to this side. And then also we're going to have -2 from the third bracket, so it's going to come over to the other side as 2 as well, so that's going to be +1 times 2. Okay, so we're sort of bringing that over. And we can equate that, and let's do that now. So that's just 9 plus 2 plus 2, so that'll be 13. And that there will be the equation of the line. So -3x, sorry, the equation of the plane. I keep saying line, my apologies. That is the equation of the plane. Okay. So what's the fast way to do it? The fast way to do it is that you'll notice that, what color haven't I used? I'll just highlight it. You'll notice that all this stuff here, right? Think about where those numbers come from. That has come from our perpendicular vector, okay? So this vector here, our normal, that's -3, 1, -2, -3, 1, -2. So we just can write those directly down. We can just put them straight down and get your answer for the algebra component of that, I guess, and where that goes. And what about the other side? Well, the other side, where that comes from, is that if you look a little bit carefully, what it is it's, I get a different highlighter here, but it's this -3 here multiplied by the x0. So you get that a multiplied by the x0. You see that? And they sort of multiply together, the 1 times by the 2, and the -2 times by the -1. And so you'll sort of see that. Oh, I made a mistake. I've made a mistake. Sorry, my apologies. I'll just go and fix that up. I said before that -3 times -3 was 9. Maybe that should be negative over here. My apologies. So just in there. So -3 times 3. So now I'll go back to what I was doing. -3 times 3, and then 1 times 2, and then -2. And so I could write this as -1 here. -2 in there. And you'll see that's the sort of the quick way that we can quickly get to the answer. I hope you can see that, because I'll give you the actual formula for it now, but that's actually gives us our quick way. And this happens every time we want to find one. I might just write it down here below, so that you can sort of see what happens. Okay, so in red, in general, if you've got your normal as being ax plus, AI plus bj plus ck, if that's the normal that you've got, and going through, and point P0 is on the plane, and point P0 is x0, y0, z0. If you've got those two, then the equation of the line, the equation of the plane, keep saying that, will be ax plus by plus cz. That was our algebra component on the left-hand side. It's going to be equal to a times x0 plus b times y0 plus c times z0. And you'll see the symmetry there. You'll see that, the symmetry between those three things. And that's the fast way to be able to quickly write down what the equation of a plane is, and we write it down there. And just a couple of notes is, and then when you figure that out, you just put all those things together, you multiply them out, and you get a number. And just with that there, we just want that to be a positive number. That's a convention to write it like that, and you'll see why sort of when we start using equations of a plane that it's much nicer, easier to work with, and makes more sense when that number is a positive. So you can just negate everything on the left-hand side if you get a negative number. Just last thing for this video that I just want to talk about is sometimes when you've got a plane, you'll be asked to get the equation and you'll just be given 3 points on that plane and have to try to find the equation of the plane. And so what do you do in this situation? Well, remember, to be able to find it, you need to know what the normal is. You need to find the equation of a plane. You need the normal, and you need a point on the line. Now you've got 3 points here. Let's just say A, B, C. You've got 3 points on the line. You know what you've got there, so that's fine. But how do you find the normal? How do we get the normal? Well, remember that we can find the normal to any 2 equations if we find the cross product. And so we can get the cross product. Damn, I've hit the top of the page. I hate when that happens. I'll just cut to there. We can find that normal by going BA cross BC. That will get us our normal. So that'll be equal to the normal. So if you get in a question where you have to try to find the equation of the line, when you're given 3 points, find BA or AB, whatever it is, and then BC. Find the cross product of those 2 vectors, and that will give you your normal. Once you've got the normal, you have already got another point. Just choose any of your points and go back and follow the process above for finding the equation of a plane. Hope that makes sense. See you in the next video.